Okay, so Royal Mint, Llantrys in South Wales, they make all these coins, right? British coins, and in 2013 they estimated the number of coins in circulation, all right? And this is talking about in millions, isn't it? So £2 coins, there were 394 million of them in circulation. So one particular coin is selected, so one of these here, and it says the total value of the coins in circulation of this selected coin was greater than any other coin. So which one was selected? You can see it's bolded here, and I've underlined it as well. So they don't put the total value of it, okay? Not obviously the coin value itself, right? Obviously £2 coin is the most valuable, but in terms of how the total value in circulation, if we take the £2 coin, there are 394 million of them in circulation. In terms of the value of that, well, each coin is worth £2. So if you've got 394 of them, you would do 394 million of them. You multiply, wouldn't you? 394 million by £2. So if you multiply this by 2, I think you get 788, if I'm correct. Million, of course, right? I won't write that down, but you get 788 million of them. Now, pound coins, all right, now we don't need to multiply them because it is just one, isn't it? But we've got 1,526 million of them, so 1,526 million pounds. So obviously that's sort of in the lead, isn't it, there? And 50 pence, there's 920 million of them. Now if you think about it, 50 pence is like half of a pound, isn't it? So in terms of how much this value is here, we'd need to halve this, yeah? If we halve this, that would give you the total value in pounds. So half that, you get, I think that's 460, okay? And here with 20 pences, I mean, there's loads of these in circulation, 2,704 million, but they're only worth 20 pence. It takes 5 of them, doesn't it? It takes 5 of them to make a pound. So we'd need to divide this by 5 to work out how many pounds there are, okay? If you divide that by 5, I think you get roughly about 541 roughly, right? It's something like that. It doesn't matter here, right? We're not interested in the exact. 10 pence, now 10 pence, of course, to make a pound, you need 10 of these. So we need to see how many, we've got these amount of 10 pences. To see how many pounds are there, we need to divide this by 10, yeah? Because 10 pences make a pound. So if we divide that by 10, you get 159.8, okay? And you can see how this goes. You know, this one you'd have to divide by 20, okay? And if you divide that by 20, well, divide it by 10 first, you get 381.3, divided then by 2, you get 190, so it's nowhere near. Same here, you know, you'd have to divide that by 50, and a penny, you'd have to divide that by 100, wouldn't you? And so that would be quite low. When you divide it by 100, it'd be 112.93. So the one in the lead is that one there. That's the most valuable, the pound coin. Okay, so that's how you can sort of reason that out. I know it took me a long way to explain that, but you can write here and reason out which is the most valuable in terms of the total, and circle that there. So it says in part B, Harry has a gold coin. It weighs 8 grams. What does this weigh in kilograms? So obviously a kilogram, if you think about it, 1 kilogram is 1,000 grams. Okay, so we need to remember that K stands for 1,000. 1 kilo is 1,000 grams. So 8 grams is obviously a lot less than 1,000. So it's a fraction of 1,000, isn't it? In fact, it'd be 8 out of 1,000. So we need to write that as a decimal, first of all, before we put this in standard form. If you divide by 1,000, it moves 3 places, doesn't it, to the right. So you get 0.08. Okay, that's how I'd write that there as a decimal, because 8 divided by 1,000, if you start with 8 here, it moves 3 places, 1, 2, 3. Or the other way you can think of it, this is the tenths column, this is the hundredths column, that's the thousands column, so 0.008. So then you've got that, but in standard form, of course, with standard form we want the decimal point here, don't we? Okay, so we need to move the decimal point 1, 2, 3 places. Okay, so 3 places there, so it'll be 8 times 10. 3 places is moved, but because it's a really small number, it's going to be minus 3. So this is my answer here, okay? And then it says, part C, how many of these coins could the Royal Mint possibly make from a gold bar weighing 2,460 grams? So we need to see how many 8, you know, remember now there's 8 grams, so how many 8 grams is in here. So you just need to do the bus stop method. So let's do it. 8 into 2 doesn't go, 8 into 24 goes 3 times. With no remainder, goes into it perfectly. 8 into 6 doesn't go, doesn't it? 8 won't fit into 6, so it doesn't go, so 0, so we carry that 6. And then 8 into 60, 8 times table, 8 times 7 is 56, so it'd be 307. But 56 means there's 4 left over, so 4 left over, put a decimal point, big 0, and put the 4 there, and decimal point up there. And 8 into 40 then goes 5. So there's your answer there, 307.5. You might be wondering, well, my answer isn't here, so maybe I've gone wrong. But if you think about it, you can't make 307.5 coins, okay? You can only make a whole number of coins. So you've got to round this, right? And we're going to round it down, in fact, because you wouldn't round it up. Because if you round it up, 308, you can't actually make 308. That's the most you could make, okay? You haven't got enough gold to make 308, so we'll round it down and we'll have a little bit of gold left over. Okay, part G, another gold bar has a mass of 3.86 kilograms and a volume of 200 centimeter cubed. Calculate the density of the gold of the bar. So now density is mass divided by volume, okay? So you could see, actually the formula comes here, doesn't it? Because grams represent mass, centimeter cube represents volume, so it's mass divided by volume, which is what we've got here. Now the mass needs to be in grams. Now that's 3.86 kilograms. So that's no good, it's in kilograms, so we need to times 3.86 by 1,000. Okay, so we get 3,860 grams. Okay, so now we've got it in grams and the volume is in centimeter cubed, which we've got here. So then the density will be the mass, 3,860, divide them by the volume, which is 200. Okay. Now there's lots of ways you can do this. You could cancel off zeros here, okay, if we wanted to start with. So you end up having 386, then divide by 20, and then if you want to divide by 20, the easy way to do it is to do 386, divide by 10, and then divide by 2. Okay, that's the easy way to divide by 20. Divide by 10 first, and then halve it. So effectively you divide by 20. If you divide by 10, that becomes 38.6, and then divide by 2. Divide that by 2, you get 19.3, okay, grams per centimeter cubed.